The first Resident Evil game was one of the most revolutionary horror games ever made. Even with its many unique things like its resource managing survival horror gameplay loop, the thing that comes to everyone's mind when you mention the first three Resident Evil games is the static camera and the tank controls. While some might think it's outdated and best left in the past, I think it's one of the best ways to control and present a horror game. Not only does it allow the developers to perfectly direct what the player sees, but it also builds a lot of tension since you can't just peek around the corner. To really show the advantages of a static camera off, let's compare it to a standard first-person view in the same scenario. In first person, seeing the red substance on the ground makes the tension rise, but all that tension is gone the second the player gets a bit close to the corner. Meanwhile, with the static camera, we get the same amount of tension when the red substance is revealed, but instead of it dropping off, it keeps rising until the player eventually turns the corner. The example I use is actually what we are going to be making during this video. By the end, you will have a player that controls just like this, along with a camera system that has trigger zones, multiple modes, and some fancy gizmos. I don't want to waste any more of your time, so let's get straight into the tutorial. Let's start out by making our player. First, let's make a simple platform for our player to stand on, then let's make the capsule that will become our player, and let's add the character controller component to it. And I'm also gonna add some cool sunglasses to him just so we know which way he's facing. Next, let's create a new script called player movement that we will attach to our player. Next, let's open the script up. It's a good practice to add dependencies in as required components just to make sure they are never missing, so let's add the character controller in as one. Next, let's create the variables we need. First, we need a float for the player's movement speed, then another float for the player's turn speed, and lastly a reference to the character controller. Then in the start method, let's set the reference for the character controller. You might be thinking, why not just make the variable accessible to the editor and assign it there? And the answer is to prevent human errors. Humans are forgetful, so it's best to make the code do as much of the tasks on its own as possible. I'll also add a tag to the flows that makes them appear as sliders in the editor. You don't have to do this, but it makes the values much easier to edit. Let's continue the main script now though. We'll use the character controller's move function since it automatically handles collisions and ramps. In update, let's call the move function. We will pass in our transforms forward, multiplied by our current vertical input, multiplied by our move speed, and lastly multiplied by time.delta time. This will result in the character controller moving forwards or backwards based on if we are pressing W or S. The character controller component doesn't have gravity on its own, so we will quickly add it as another move call, but this time it's the inverse of the global up multiplied by 9.7, which is Unity's default gravity number. Next, let's implement a tank-like turning. Since our move function already uses the forward direction of the player, all we need to do is rotate the player's transform based on our input. We will do this by calling our transforms rotate function and passing in 0 for the x, horizontal input multiplied by our turn speed and multiplied by that time as y, and 0 as z. And with this, our player is basically done. I said basically since he's still just a bean. Let's fix the building in the model for him and setting up some animations. Let's drag in the player model and drag it under the player's capsule. We should also zero out its position so it's perfectly centered. My model was looking the wrong way, so I will also make him face the forward direction of the capsule. Let's also get rid of the test visuals like the sunglasses and the renderers on the capsule. Next, we are going to set up some basic animations. I don't want anything fancy, so I will only add the walking one, but you can add more if you like, for example stuff for turning in place. Let's open our player's animation controller. If yours doesn't have one, you can create a new one and drag it on the player. You will also need to drag any animation clips you want to use into this controller. Let's create a new bool parameter called isMoving. We will use this to transition between our idle and walk clips. Next, let's set up two transitions, one going from the idle to the walk and one the other way around. Then you should set up the conditions for both the same way as I do. Then in our movement script, let's create a reference to the animator. This time we will assign it manually since the animator is not on the parent object of the script. Next we will call the setBool function in our animator which can change any parameter in it. We first need the name of the parameter, so we will pass in isMoving, then we need the new state, and for that we will pass in if our vertical input is used. And just like that, our player animates when moving. Now that we have our player fully finished, let's dive into making our camera system. We will start by adding an empty game object that will store all the stuff we need for our camera zone. Let's also add in another empty game object that will be the position of the camera when the player is in this zone. Lastly, let's add in a cube that will strip down to only its collider and rigid body. This will be the zone the player needs to walk into to transition into this area. Next, let's make a script for the camera zone and open it. First, let's make an enum that stores our camera modes. I will show 3 modes in this video, but you can make as many as you like. Next, let's make a variable for this mode setting, and let's make another one that will store our camera position transform. Let's make some more variables that will store our player's head, and our camera. We will assign all of these in the start function. Let's also quickly create the player ahead object and position it a bit ahead of our player. Next, let's make the function that will update our camera. We will first check if the camera is assigned, and if it's not, we will assign it. Then, we will update our camera's position and rotation to match the position and rotation we want it to be at. And lastly, we will make the camera a child of the transform that was the position and the rotation. I will also add in a context menu header, which will allow us to call this function from the editor, which makes it a lot easier to edit the position of the camera. Then in update, we will make a switch statement that takes in our camera mode and makes our cam pose look at either the player or the player's head transform depending on the setting we use. Since our camera will be parented under the cam pose transform, this will make it also look at the desired object. To finish things off, let's add in the onTriggerEnter function. In here, we will check if the thing that entered the trigger is tagged as our player, and if it is, we will call the updateCam function. Back in Unity, let's select the trigger object and let's add the camera zone script to it. Let's also assign the camera position and let's set the mode to follow player. I will position it in the corner for testing purposes. And just like that, the camera system is working too. But it's still a bit hard to see where things are in the editor, so let's quickly add some gizmos. Let's make an onDraw gizmos function. Unity will automatically call this even when we are in the editor. Then in this function, let's check if we have our camera assigned, and if we don't have it, let's quickly get it. Next, we'll make a switch statement that will set the color of the gizmos based on our camera mode, just to make it easier to tell things apart. Then let's make a line that will connect our trigger area to our camera position. After that, we will set the matrices of the gizmo to use the matrices of the trigger zone's transform. This will automatically make it use the position, rotation and size of the object. Next, let's make a wire cube that will be at position 0 and the scale 1, since we already got those from the matrix. And lastly, let's set the matrix once again, this time to the matrix of our camera position. Next, let's draw a wire speed at position 0 to show our camera position's center, and to finish things off, let's draw a view frustum at position 0 with our camera's field of view, and with 1.5 as the far end, 0.1 as the close end, and 1.777 as the aspect ratio. If you go back to Unity, we'll see that everything is shown correctly, and if you change the camera mode, the color changes as well. I will quickly make an ugly test area just to test all the modes out. As you can see, the camera switched correctly and also used the correct mode. And with that, I think this tutorial is just about over. If this helped you, please leave a like. Honestly, this video took a bit too long to make, because just as I was getting into the groove of working, Valve decided to drop Deadlock, and I've gotten a tiny bit hooked on it. My next video is still quite a bit away. I'm currently working on a short horror game about drilling into a moon that's alive, and that's what it will probably be about. If that idea sounds cool and you wanna see a video about it, please subscribe so you don't miss it when I get it done. Anyways, thanks for watching.